Okay, today we're going to talk about how we find the intercepts of a line and how we find the intercepts of an equation. So our vocabulary is X intercept, Y intercept, X axis, Y axis, axes, which are axis is the pluralized version of axis. So you have one axis and you have, two or more axes. And slope intercept form. Okay, so if I look at a graph, so any graph that is not parallel to one of the axes intersects both axes. Okay, so this line right here is not parallel, right? Parallel lines are either vertical lines or horizontal lines. If it's a vertical line, it intersects an axis only once. It intersects the x-axis. If it's a horizontal line, that it will intersect right here. Okay, but any line that is not just a straight, well, every line is straight, but every line that's not a vertical or a horizontal line will intersect both the x-axis and the y-axis. Okay, so this right here with this line, this is the point of intersection with the x-axis, and this is the point of intersection with the y-axis. Okay, that's what we call the intersection. Now, the y-coordinate of the point where the line intersects the y-axis is called the y-intercept. This arrow is a little off here, so it should be pointing to this point right here. So here I've written down the, oh actually no, the arrow's on, it's pointing to the y coordinate. Here this point has coordinates 0, 4, right? It would make sense that the point, the x coordinate was 0 because the point is on the y-axis, and every single x coordinate on the y-axis is 0. Okay, but it's 4 units up along the y-axis, so it has the coordinate 0, 4. So we say that the y-intercept is 4. Okay, we're only referring to the y coordinate of that point. That's because the x coordinate is not really interesting to us because we know it's always going to be 0. The x coordinate of the point where the line crosses the y-axis is always going to be 0. Okay, but what is interesting to us is the y-coordinate. Okay, likewise, the x-coordinate of a point where the line intersects the x-axis is called the x-intercept. Okay, so this right here is the x-intercept. It is the x-coordinate of that point. And similarly, we have the y-coordinate is equal to 0 because every point on the x-axis has a y-coordinate of 0. In fact, another name for the x-axis is the line y is equal to 0. We saw that a few lessons ago. So all of these coordinates are 0 for your y-coordinates. So what's interesting to us for the x-intercept is the x-coordinate. Okay, so we would say that the x-intercept of this line is equal to -3. We don't mention that it's the point -3 comma 0 because we know that the y-coordinate is always 0. Okay, so finding the x and y-intercepts from a graph, I would just look at this. I'd say that point is 0, 2. So the y-intercept is just that y-coordinate. So the y-intercept is 2. Likewise, this is the point 4, comma 0. Okay, so the x-intercept is just the x-coordinate of that point. Whoops. So that's just 4. Okay. Here it's a little trickier because the line actually passes through the origin. Now this point right here is the point 0, 0. Okay, so for the x-intercept we say that's the x-coordinate, that's 0. For the y-intercept we say that that is also 0. Okay, so let me just give you an example. Let's say that I give you a line and I tell you that the line has an x-intercept of 0. Okay, that means the point where it crosses the x-axis is 0, right? So if I say, okay, there's this line and the point where it crosses the x-axis is 0, so the line must go through this point right here when it crosses the x-axis. Well, you know automatically that the y-intercept is also going to be 0 because if it crosses the x-axis where the x-coordinate is 0, okay, it doesn't really matter what the y-coordinate is. If the x-coordinate is 0, you know that that point is going to be going through the origin. In other words, if the x-intercept is 0, you know the y-intercept is 0. Likewise, if you know the y-intercept is 0, if you're given this information, you know automatically the x-intercept is 0 because it must go through the origin. Okay, if I have an equation, now there's a couple different ways I can figure this out. First of all, if I have an equation in standard form, what's pretty nice is, remember, to find the x-intercept, it's the point where I'm looking for the x-coordinate when the y-coordinate is 0. Right? That's what the x-intercept is. Like, where does it cross the x-axis? So let's say I have a line and it crosses here. Well, the distance away from the origin horizontally is not known, but we know the distance away from the origin vertically, right? It's always 0. So the x-coordinate is some number we don't know, but the y-coordinate 0. So if I'm trying to figure that out, well, all I have to really do is plug 0 in for y, because I am looking for the value of x when y is 0. I'm looking for the value of x when y is 0. So I'm asking myself, well, what is this? This is similar to when we first started working with equations, and I'd ask you, okay, what is the k value if I know this point is part of the solution set for this equation, what is the k value? It's almost identical to that question. Like, what is the x value when the y value is 0? So here I want to plug this in. Okay, I know it's an element of the solution set because I know it's on the line. Now I solve this equation. 2x minus 0 is just 2x. And divide by 2, x is equal to 3. Okay, so the x-intercept is 3, and I also know that the point 3, 0 lies along that line. Okay. Likewise, I can, for the y-intercept, I'm wondering, okay, when x is 0, what is that y value? So instead of plugging 0 in for y, here in this, to find the x-intercept, I'm going to plug 0 in for x. Okay, so this is 0 minus y is equal to 6. Now, if I want to solve this, to make the y positive, I can add y to both sides. So I have 0 is equal to 6 plus y. I can subtract 6 from both sides. 0 minus 6 equals y. Well, 0 minus 6 is negative 6. Okay, so y is equal to negative 6. That's one way I can do it. I can also solve the equation for y in terms of x. Or I can put the equation in a form that's called slope-intercept form. And so if the equation is given to you in standard form, then you can choose to put it in slope-intercept form, because when it's in that form, so this is what we call slope-intercept form, y equals mx plus b, okay, where m is the slope and b is the y-intercept. So it's some coefficient to x plus some constant. Okay, when it's in this form, the b is the y-intercept. All right, so if I were to solve this equation that's given in standard form for y-intercept form, I want to solve for y, right? I want to get y by itself. So the trick here is, okay, so if you're subtracting y, the best first move that you can do is adding y to both sides. So here I'd have 2x is equal to 6 plus y. In this case, it makes the y positive. Now I can subtract 6 from both sides. So I'd have y is equal to 2x minus 6. Now, since the equal sign is reflexive, meaning I can move things around the equal sign, I can rewrite this as y is equal to 2x minus 6. Okay, so in this case right here, the 2 right here is the slope, and this the negative 6, actually, in order to be in slope-intercept form, this has to be addition. So I'd have to actually take this one step further and do keep, change, change here. So it'd be y is equal to 2x plus negative 6. So here is the slope, and the y-intercept is negative 6. We're going to talk more about this in the next lesson, but I just wanted to give you sort of a feel for it right now. Okay, and look how this confirms what we got right there. Okay, likewise, it would help us find the slope. If we were asked to find the slope, if we were asked to graph the line, having the y-intercept and the slope we're going to see in the next lesson is very helpful to go directly from the equation to the graph without using a table. Okay, so there's two methods of doing it. You can plug 0 in for y, and that gives you the x-intercept. You can plug 0 in for x, and that gives you the y-intercept. Or you can solve it for slope-intercept form. In the next equation, so let's try the method number 1. So to get the x-intercept, I have to plug 0 in, let y equal to be 0. So 0 is equal to negative 3x plus 8. Okay, I subtract 8 from both sides. 0 minus 8 is negative 8. Okay, and I divide each side by negative 3. I'd have x is equal to negative 8 over negative 3, which is just 8 over 3. Okay, so if it's I can keep it like this, or I can change it into a mixed number. You don't want to change slope into a mixed number, but you can change the x and y intercepts into either a mixed number or a decimal, because you have to plot them on the graph, so it's easier to do that. Whereas slope you want to keep as a ratio because it's the numerator and denominator tell you two different things. So here 8 goes into 3 twice, you'd have 2 over 3 remainders. So you can write this as, you can estimate it as 2.67 because it's 2.6 repeating. Okay, and if you were to plot this, if I gave you x and y axes and you were to try to plot this, the x-intercept would be, you know, 2 points, would be something like this. So we know that the line crosses the x-axis at that point right there. Okay, for the y-intercept, we want to set x equal to 0. Okay, if I did that, you'll see very quickly, okay, y is equal to negative 3 times 0 plus 8. Okay, so y is equal to, this term gets to be 0, right? 0 plus 8, okay, y is equal to 8. And that's why when it's in slope-intercept form, that constant right there is equal to the y-intercept. I can just pick that right off, okay, because if you put 0 in for x, it knocks out that term entirely, and you're just left with that constant, right, because the constant doesn't have the x on it. So, so we know that this line passes through 2.67 on the x-axis and 1, 2, 3, 4, 5, you just extend it here, 6, 7, 8 on the y-axis. So you can sort of graph, not sort of, you can graph the line right here. So this is the line y is equal to negative 3x plus 8. And notice there are some things that you can visually check. Well, the slope is negative, which makes sense because this line is decreasing. It's fairly steep, and that makes sense because for every 3 you go down vertically, you go across 1 horizontally. That's what that slope means, negative 3. Okay, so let's try another problem here. I give you an equation in standard form, and you have to find the x and y intercepts. Let's use method number 1 for this one. To find the x-intercept, you set y equal to 0. This might be a point where you want to stop the video and try this on your own to get some practice on this. Okay, so 5x plus 2 times 0 equals 10. 5x plus 0 equals 10. 5x equals 10. So x must be 2 if you divide each side by 5. Okay. For the y-intercept, you want to set x is equal to 0. So 5 times 0 plus 2y equals 10. 0 plus 2y equals 10. Y must equal 5 if you divide each side by 2. Okay, so if I were to graph these lines, I'd make a dot 2 along the x-axis, and I'd make a point 2 along a 5 along the y-axis, and I draw a line in between them. Okay, and there's my line, 5x plus 2y equals 10. Okay, slope-intercept form, like I said before, is a linear equation is in slope-intercept form if it looks like this, where you have a coefficient to the x, and you're adding the constant right there. M and B are real numbers. Okay, so they're not, the only variables that stay in here are x and y. Okay, because those are an infinite amount of solutions, they're an infinite amount of coordinate pairs that make this equation work. So M and B, though, are actual numbers that are in there. and they're real numbers, so they can be integers, they can be decimals, they can be rational numbers, they can be irrational numbers. So I could have pi if I wanted for m and b, or I can have like the square root of 2 or something like that, because they're real numbers. Okay, so if we're given an equation in this form, it ends up being pretty easy to pick off slope. Slope here is -5, okay, and the y-intercept is 10, right? When it's being added, I can just pick off that number right there. So slope for the next one is 1/2, and the y-intercept is 1. Slope for the next one is 3. Now we encounter a little problem because this is being subtracted and the general form of the equation is being added, but that's not a big deal because we can use keep, change, change in order to change subtraction into addition. Okay, so the y-intercept is -4. Okay, now for the next one, this doesn't have, so it has to be in the form y equals mx plus b. This one doesn't have, the next one is not in that form, but I can make an equivalent equation by adding 0 as the b, so the slope is -5 and the y-intercept is 0. By the way, so now you know it goes through the origin, because if the y-intercept is 0, the x-intercept also has to be 0. So this is a steep line that's decreasing, okay, and the and it goes through the origin. Okay, so here y is equal to 3. So how do we force this equation to be in that form? Because it doesn't have an x in it. Well, you can say it's y is equal to 0x plus 3. Okay, in this case the slope is 0 and the y-intercept is 3. And this should sort of jog your memory, because the line y is equal to 3 is a horizontal line that's parallel to the x-axis. And we said that horizontal lines have a slope of 0. Okay, x is equal to 1/3. Let's think about what that looks like. That's a line that's a vertical line at 1/3. It's parallel to the y-axis. So here, there's actually, the slope is undefined, because in a vertical line, the slope is undefined. And there is no y-intercept because it's parallel to the y-axis. So there's no y-intercept. We can actually write none here. Okay, remember this line is not a function. Okay, so that concludes our lesson today on how we find the x and y intercepts from a graph and from an equation.